All right, folks, we're going to get things started here. We're just building a little bit of audience on this Monday morning. I hope everybody had a great weekend. Hang in there just 1 second. We're going to get started. And today we're talking about a topic I think a lot of folks here in the Mid-Atlantic very interested in: hurricanes. All right, and I think we'll go ahead and get things started. I see Peyton's in the house, Alan's there, Cheryl Moeller joining from St. Louis, Missouri. Good to have Mom in the house. Lots of other folks as well. Teresa, Kim, Lori, just checking a few of the names there. And we love, love, love to have all the kids from all across the country checking it out. Let's go ahead and reveal here at the Weather Center in the 13 News Now studios. We are located in Norfolk, Virginia. For those of you watching from other parts of the country and around the world, want to welcome everybody to our weather school. We've done 24. This is our 25th weather school, and we've got a lot more planned over the next few weeks. And then we're going to test your knowledge as we wrap things up by the end of May. So a lot more to talk about. This week is something we've been very excited about since we first started putting together our weather schools. We said, you know, why don't we do a week that focuses on severe weather? That was one of the weeks we did. And we did another week kind of talking about analysis and forecasting some different things. This week, we're going to focus on hurricanes and the hurricane season. And there's going to be a lot that we're going to go over. I'm saving some of the information for later because there's all this cool stuff I want to share right away. But we're going to spread it out a little bit over the upcoming week. So today, really focusing on hurricanes and hurricane formation, how these things come together and what they do. And you see here just a beauty here behind me, the spinning hurricane, and you see a well-defined eye there. We're going to talk about all of this. First, though, let's talk about some different terms that you may encounter as you're watching hurricane coverage. You may hear about a tropical wave or hear about a tropical disturbance, an area of investigation. This is something that's really been more recently discussed because as the Hurricane Center puts out discussions and more media are talking about some of these things going out, and you have access to this at home, you can go to the National Hurricane Center's website. Great information, a lot of technical discussion about it, but if you're interested in hurricanes, you can learn a lot just by going and reading their discussions. Of course, we hope you're watching 13 News Now because we'll break it all down and put our thoughts on some of the different projections and forecasts as well when we get into the hurricane season. And I will tell you, Jeff, Evan, Tim, Rochelle, Peyton, and myself, we've been at this a long time. And really, it's, you know, with the focus here on Hampton Roads, there's a lot of value to tuning in locally. But at any rate, some of the different terms: tropical wave, just a wave of lower pressure moving along maybe over some of the warmer waters down in the tropical zones. Okay, you get a disturbance where you start to see maybe a low-level cluster of storms starting to develop, a low-level spin. Maybe we get a little disturbance there. An area of investigation, that means something's starting to come together that we believe we could see more development. And with it being an invest area, the Hurricane Center starts running their models on that, taking a look and specifically putting a lot of their effort and focus on that area of investigation. So that kind of kicks it up a notch. You take a look and say, okay, it's an area of invest. They're going to go and start running their hurricane forecast guidance on it. Okay, potential tropical cyclone. We're going to asterisk this one. I'm going to come back to that because it's kind of a special situation. But basically, you could see a tropical cyclone developing and impacting areas. So we'll talk more about that in a bit. These are the three that we'll focus on right now: tropical depression, tropical storm, and hurricanes. So let's talk about these, and we'll start with a look at a tropical depression. So basically, you have this tropical system coming together, but it's still really weak. I mean, you think about this. Tropical cyclone, sustained surface winds 38 miles per hour or less. Now, we talk about sustained winds. Those are the winds that are blowing consistently versus like a real quick gust. You could have higher gusts, but those sustained winds up to about 38 miles per hour. So certainly some wind associated with that tropical depression, but it's not terrible. It's not going to do a lot of destruction, not a depression in itself. Now, it can produce some rain, and rain is a whole nother impact. So we'll talk about impacts and how these tropical systems do damage to coastal areas and how they impact all of us. That's, again, another day later this week. But anyway, tropical cyclone, sustained surface winds, 38 miles per hour or less. Then you get up to a tropical storm. Now, a tropical storm is cyclone, same thing, an area of low pressure, tropical structure. All right, sustained winds at the surface now, 39 to 73 miles per hour. Now you're starting to get into a situation where there could be some damage, certainly a lot of rain, and we've had devastating, I mean devastating flooding from tropical storms. So you think about hurricanes being those super destructive storms that wipe out communities and do all kinds of damage. Very true. However, tropical storms can have huge impacts on regions as well, especially in terms of flooding. And that can be a very serious situation, even though the winds are between 39 and 73 miles per hour. Well, a hurricane, guess what? You get winds over 74 miles per hour, 74 or higher, and they can get a lot stronger. I'm going to show you the records for the hurricane strength that we have coming up a little later in this update. So I'll let you know just how strong those winds can get. But the hurricane's obviously the most mature of these storms. You could get into, the Cat 5 hurricanes and super typhoons, and that's the high end. So speaking of hurricanes and typhoons, we say it's a name for a tropical cyclone. Not every tropical cyclone with winds over 74 miles per hour, 74 and higher, is a hurricane. You can see they can also be called a typhoon. Now, I mentioned that. So, what's the difference between a hurricane and a typhoon? Well, the name is dependent on which basin it forms in. In the Atlantic, or the Eastern or Central Pacific, we call it a hurricane. In the Western Pacific, it's called a typhoon. Other parts of the world have names as well. Some call them cyclones. Some call them, like we said, typhoons. In Australia, they can call them willy willies. There's different names and nicknames for these tropical systems around the world. Here's a question, though. What happens when a storm forms in one basin and it moves into another? You guys have any guess? Let's see what you guys are thinking. And I see Peyton is in on the discussion, so maybe she's answering a few of your questions as well this morning. What do you think? What happens if you've got a system that develops it's in one part, forms in one basin, but then it moves into another basin or another part? Do you think it's still a hurricane, or do you think it changes? What do you guys think? Any guesses? Well, while you guys are thinking about that, I'm going to reveal the answer, okay? When a system develops, when a hurricane becomes a typhoon, well, it happens when it crosses the international date line. So it does happen. You have a hurricane, then when it crosses the international date line, it becomes a typhoon. And this has happened on numerous occurrences. So this isn't even all that rare. It happens where you get a hurricane that forms in the Atlantic, in the Eastern or Central Pacific, and then it crosses the date line, and then it becomes a typhoon. Pretty cool. All right. So what do you need to bring a hurricane together? All right, you need some ingredients here, and these tropical ingredients include warm ocean water. You need to have warm sea surface temperatures. You need a low-level disturbance. It might be a few little random storms that pop up, maybe a little low-level spin. You could have a little area of low pressure that comes off the African coast. Different things happen, but you need a little low-level disturbance moving over warm water. There needs to be lots of moist air throughout the atmosphere. That moist air, that humidity helps fuel this thing. And light winds aloft. We're going to explain why you need light winds high and a low-level spin. So warm surface water, low-level spin, some moisture to work with in the atmosphere, and light winds aloft. You'll see how all of this comes together. Take a look here. Here are a couple of the basins, and again, there are more around the world, but I wanted to focus on these two areas. You have this area shaded in green, and you have this area shaded in yellow. This is the Pacific Basin, All right, and we get a lot of tropical systems that develop down here, and then they kind of move up, and a lot of them just kind of wind down up in the northern Pacific. They'll kind of pass north of Hawaii and then weaken or whatever, but sometimes they form and they keep cruising, and they do threaten the Hawaiian Islands. So this is the Pacific Basin near the Mexico here in the Baja. You see that? And then you have this area shaded in green. And for all of our Facebook friends that are watching right now, here in the Mid-Atlantic, this is the area that we're most concerned with. Now you can see the Atlantic Basin doesn't just include the Atlantic Ocean. The Atlantic Basin also includes the Caribbean and the Gulf of Mexico. And we get disturbances throughout this entire region that can impact the United States and Hampton Roads right here in the Mid-Atlantic. So this is why this area is of such great importance. Now, depending on where we are in our hurricane season, whether it's early, late, middle part, okay, that changes where we look to in the basin for most of our development. And again, we're going to break down our season tomorrow. We're going to talk about what parts really get hot at different points of the season. Some early season, some later season. It all comes down to what time of the hurricane season this stuff works out. So again, we'll have more on that. All right, so how do hurricanes come together? We mentioned you've got to have some warm, moist air, and that is fed. A lot of this energy comes up off of this warm sea surface. So as this comes up, get a little bit of convection, maybe you start to see some rain areas or some storms develop, and you see more and more of this. Got to have a lot of moisture here through this column. Again, it continues to draw this up, and the wind must be light, way up high to prevent the system from shearing apart. Okay, when you have winds that are blowing, it disrupts the structure of this, and it can't really form. The critical water temperature for these storms to develop and get stronger and stronger, you need to have that water, the ocean temperatures at the sea surface, 80 degrees or warmer. That really does it. Sometimes it can be a little bit cooler than that, and you could still have systems kind of holding together. But pretty much 80 degrees, that's what we think about as the cut. So when you get into the 80 to 85 degree temperatures, 82, 83, that's where this thing's really got all this heat and energy to supply to help these storms get stronger and stronger. All right, so we get our tropical depression. Again, you get the clouds and some showers and storms that are developing, and you get a circulation. That circulation starts to close off. There might be just an area of low pressure, but as we get it better organized, it becomes tropical depression, and then eventually it develops into a tropical storm. As we mentioned, now those thunderstorms are really getting wrapped around. Okay, you get a closed circulation, and you're looking at these winds now 39 to 73 miles per hour. As I mentioned, eventually you get those stronger winds, and the hurricane continues to develop. Strong circulation. We look for some venting aloft, and we'll show you the profile of a hurricane kind of from the side here and help you see that. But you have these very powerful winds, all of this coming in, and this thing, it's almost like a big straw where you get all this air getting sucked up. You've got sinking right in the middle, and that's your eye. So very, very interesting. Now, this is how this works. Again, you've got the warm, moist air coming up off the ocean surface, okay, and it rises up. This water vapor goes up. As the vapor cools, it condenses. You get some liquid droplets. Condensation releases more heat, and again, that air continues to get higher and higher and higher, and we continue to see this development. And this is what it looks like if you were to cut the hurricane in half. You would have all of this wind near the surface coming into this. You would have the air inside spiraling up. When it gets up to the top, it vents out. And what's really interesting, all right, when you think about a hurricane, we've got our, what kind of winds? Think about it, low pressure. We talked about this before in the northern hemisphere, north of the equator. So our hurricanes north of the equator, all right, that spin at the surface is counterclockwise, right? So the winds are spinning around this way, and you can see how it does that. But when you get to the top of this thing, when it starts to vent out, you get some cooler air right up the top, very top of this hurricane, it vents out in the opposite direction. So when you're looking at a satellite image, at the surface, you're going to have these winds spinning this way, but at the top, you see the clouds fanning out the opposite direction. Very cool, very easy to spot from a satellite image when you're looking at it. That's when you know this thing's really mature. It's venting out and you've got the low-level circulation. It's pretty awesome. All right, so we have this center part, which we've been talking about, the eye, and you can see the eye wall here. And you've got little rain bands that expand out. And you can have some of these stronger winds sometimes in some of the squalls or the rain bands. But typically, right along the eye is some of the most violent wind that you're going to see. This is an image of Hurricane Isabel. And again, folks here in Hampton Roads, Southeast Virginia, we know all about Isabel. If you were here in 03, this area got clobbered by this thing. Came in over Ocracoke Island, cut up across northeast North Carolina, came through and moved up through northern Virginia, and it did quite a number on the region. Lots of damage, lots of power outages. We got hit really hard with Isabel, and what a beautiful storm to see that with the satellite images. You saw that very clearly defined eye. This image comes from NOAA, and this is from inside the eye wall, and you can see how it's like you're on the inside of a straw here, looking up and out of it. I think that's just an awesome picture, but again, I wanted to share with you kind of what it looks like inside the eye there. Now, we talked about the winds needing to be light aloft, so we've got the circulation spinning up and then the air vents out at the top. If you've got a lot of shear, all right, the system can be sheared apart or blown apart. So those stronger winds, and last Friday we talked about El Nino and La Nina, and we said the Atlantic hurricane season, a lot of times as these storms try to develop and try to get really strong and get that beautiful venting out, they encounter more violent wind during El Ninos. Okay, there tends to be more of this shear, so it blows them apart. They don't allow them to be structured straight up and down. This is a healthy hurricane, all right? When they're sheared apart, that's tough, and they can't maintain their strength. So that's what disrupts the hurricane development when you get that strong shear. So I told you we'd come back to this potential tropical cyclone. All right, so we've got this system. May not be well organized, but if the Hurricane Center believes it could become a tropical cyclone and impact land within 48 hours, they're going to be talking about this potential tropical cyclone. And this is still the hardest thing when it comes to forecasting the intensity right before landfall. We've got great modeling stuff, and it shows us where these things are going pretty accurately. We have a good feel for where they're going to turn, if they're going to go more to the north or swing to the west or however they're going to do. But sometimes trying to determine whether they're going to get a little more intense or weaken a little bit before landfall, that can be a trick. And every once in a while we get into these situations where the system can rapidly develop, and maybe it was nothing a couple days before. We don't get a lot of those, but there is sometimes that potential. And again, the Hurricane Center also classifies these things that they think could ramp up pretty quickly as potential tropical cyclones. So again, you see this, just another classification that they've started to get into. Now, talk about rapid intensification. Well, according to the National Hurricane Center, okay, rapid intensification is an increase in maximum sustained winds of at least 30 knots in 24 hours. So you start looking at these winds jumping up 30 to 40 miles per hour in 24 hours. That's going to make a big difference. I mean, the difference between a system that has 45 mile per hour winds, tropical storm force winds, and hurricane changing from that to that in 24 hours, that's rapid intensification. So we clearly are watching for that. Very, very important. Now, I told you we'd talk about the Hurricane Saffir-Simpson scale. You got a Category 1 hurricane between 74 and 95 miles per hour. For a Category 2 hurricane, 96 to 110. Cat 3, now you're talking about a major hurricane, 111 to 129. When it's over 130 miles per hour to 156, that is a Cat 4. And when it gets stronger than that, it becomes a Cat 5. That's the largest classification, Cat 5. Again, over in the Pacific, we call them, when they get to that size, super typhoons. So they can get a lot stronger. And in general, I wanted to show you just the lifespan. And again, this is an image from NOAA they put together, but it just clearly shows what we're talking about. You get a wave. This is a Cape Verde what we call a Cape Verde hurricane because it's out by the Verde Islands. It comes off the African coast, just a wave, and then it becomes more organized as it crosses over this warm water in the tropics here, close to the equator, north of the equator, but it starts to drop more energy, more organization, starts to become a tropical depression, then it becomes a tropical storm, and this is just, again, an example of a typical kind of lifespan or life cycle of one of these tropical systems. It becomes a tropical storm. Then we watch it, oh, it's getting over this warmer water in here, becomes a hurricane. Well, a lot of times there'll be a front where we'll get some westerly winds that'll help curve this thing up, maybe bringing it close to the Carolinas, hopefully keeping it farther offshore, but then they recurve, and then as they move back out into the North Atlantic, maybe they get caught up in another system and they become extratropical. Okay, that's just a typical hurricane kind of life cycle, and then it moves up here and it weakens it into an extratropical cyclone. So that's kind of what we're looking at. Now, three different things, 3 or 4 things kind of kill a hurricane or can tear these things apart, whether it's a hurricane or a tropical storm or whatever. What do you think some of those things are? Okay, I don't have a graphic for this, but I want you to know what we look for, okay? One of them we talked about before when we said if there was something aloft, it would tend to break them up or just kind of shear them apart. Do you remember what that was? If you have that not warmer air, let's see, was it the windy conditions. Remember, strong winds aloft, wind shear will shear these things apart. So if a system encounters a lot of shear, that will weaken the system, okay? Something else. What else do you think would kill one of these things? If it were to have maybe some drier air come in, think about that. These things need that moist air. So we said it needs the light winds aloft. If there's a lot of wind up high, it blows it apart, shears it apart. If it has drier air coming into the system, we call that a dry air intrusion. We get that dry air in, it will weaken the system. That's another thing, okay? If it moves over land, what happens? It loses its energy source, right? It needs that warm water. So that's another thing that'll do it. And then the other thing is if it moves over the cooler water in the North Atlantic or some of these areas where the water temperature is a lot cooler. So those are the 4 things that we really look at a lot of times with these things. What's going to tear this thing apart? Once you have a hurricane and it's here, they don't typically just go away. Sometimes they'll kind of weaken a little bit if they churn up their own water underneath them. Think about that. You've got a hurricane moving along and it needs that warm water to continue to get energy, and if it's sitting over the same place and it's kind of just stirring up the ocean waters a little bit, maybe that sea surface temperature drops a little bit and it steals some of its own energy. But typically what will happen is you get wind shear to blow it apart, it moves over land, once it loses the ocean, once it loses that energy, it dies out. It gets drier air, and that dry air wraps into it, and all of a sudden it loses its organization there and it weakens, or it moves over the colder water. And again, losing that energy. So those are the basic things. Now, I told you we'd talk about the strongest hurricanes on record in regard to wind strength, highest sustained winds in the North Atlantic. Hurricane Allen in 1980 had 190 mile per hour winds. Worldwide, Patricia had 215 mile per hour winds. That was back in 2015. So there's a couple records. Now, I told you this is hurricane week. So we're going to talk about different things like the hurricane season, how hurricanes do damage, how we track hurricanes. We'll show you the hurricane hunters, show you some of the modeling data we look at, lots of cool stuff. And Friday, we're going to share with you the very latest on our hurricane season outlook for 2020. So there's a lot to go over this week. We're going to have a lot of fun doing it. Hopefully you guys will want to come back and spend some more time. Okay, I want to give a shout out to Peyton Domschke. There she is. Her contact information on social media. Peyton and Rochelle helps me out on Thursdays and Fridays, and Peyton's in on Monday, Tuesdays, and Wednesdays helping provide information. You can find me here on social media. Love to hear from you. If you've got questions about this, we're going to keep doing them. We're having a lot of fun with our weather school. And as I mentioned, tomorrow, we're going to talk hurricane seasons. So you guys have a good one and keep an eye to the weather. Stay safe, everybody, and we'll see you back here again tomorrow at 9:15.